me and my Sharpies. Okay. So we're going to talk about that. What we're talking about? What we're talking about is the abacus. But the first thing I want to do is cut these stupid things. It's not stupid. It's a little flippy thing that I just created. So I created another little flippy thingy. And now we're just doing some exercises with it. So the problem is we're going to be counting on the abacus. So we count on the abacus. Here we're counting on the abacus. When we count on the abacus, these are all the beads. These beads, good morning, good morning. So what we're going to do is we're going to count on the abacus. And we do 1, 2, 3, 4, and then 5. Notice all the top beads has a value of, all the bottom beads has a value of 1. The value of, oh, that's not what I want to do. Nuts. All right, this is all the value of 1. So when their horizontal bar is being, counted, touched. When these beads are touching the horizontal bar, these are being counted. So these are 1, 2, 3, 4. But the top bead will be a value of 5. Always have the value of 5, no matter what. These are all 5. That's not 5. There we go. These are all 5. This is a value of 5. These are all 5. 1, 2, 3, 4, 5, 6, 7. These are all 5. And this is a 7-column abacus. This abacus is a math tool. This math tool helps us add, subtract, multiply, and divide. It's kind of cool. Excuse me. Good morning, everybody. Good morning. Good morning. Good morning. This is the a little early in the morning, but I'm pretty charged up to talk about abacus, and I'm always out talking about abacus. So what we're doing is we're talking about abacus in the morning. We're doing Monday morning math. All right. So again, when the beads are touching the horizontal bar, this means that this is 1. So this is 1, 2, 3, 4. And then this is 5. Because the top bead has a value of 5, it's touching the horizontal bar. This is the horizontal bar. When you look at the horizontal bar, I am usually... Thank you, Beals, for the heart meet. Welcome in the morning. Welcome. Good morning. So there's a little indicator right here. If you notice my little dot right here on the horizontal bar, this horizontal bar tells us that tracks the number. And so this is a value of 5. So when we, thank you so much for liking the live. Thank you so much. So we have 5, 6, 7, 8, 9. And then we have 9. So all of these that are touching the horizontal bar is 9. But these are not 9. These are all zeros. So we do 9, 9, 9, 9, 9. These are all, there's the most that each column can have will be 9 no matter what. Thank you so much for liking the live. Good morning, everybody. Good morning. Good morning. Anybody have any questions? Beals, do you have any new questions for me? So I am looking at the abacus, and the abacus says 1, 2, 3, 4. And I always play around with my, there we go. No, that's too dark now. There we go. Okay, we're back. No, now it just blows out. That's horrible. This is horrible. Okay, there we go. Better. So when we count, we get 1, 2, 3, 4, and then this is 5. This is always the value of 5 no matter what. So when we look, these are all 5s and these are all counted. So when we look at this is 55,555. So what does that mean? Well, let's look at our little chart. Here is my little chart, and the little chart, if I line it up, it looks like that. So when I write it, it will look like this: 55,555.55. That's what this means. Huh? Does that make sense? Because these are all the top beads being, that's all the top beads are being counted. They're touching the horizontal bar. That's what that means. And I'm looking for my little wipey thingy. So when we look, right, we have 1, 2, 3, 4, and then 5. And then we have 6, 7, 8, 9. After 9, we have 10. So when we write 10, it's just like that. Just as we write 10 is how we read it on the abacus. And it's super simple. It's exactly the same. So this is 11, this is 12, 13, 14. So if this is 14, it looks like this: 1 and a 4. And then we have 15. Hey, 6, 7. No, 6, 7. 6, 7. Ha ha, Z. So what we're doing is we're reading the abacus. When we read the abacus, we're doing this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Did that make sense, Z? Hopefully you can see it. Yeah? You alright? Did that make sense? We do it again. We do it again. I don't know if you're still around, but 1. Okay, good. So what? So then after that, we'll do that. You've seen this. You've seen that this is 1. If this is 1, but this is 1, but put it together, this is 10. So if we look, we have our ones, our tens, our hundreds, our thousands, our 10,000. Thanks for the follow, Bree. So does that make sense, see? So we have 10, 20. Now I'm going to count by 10s. 20, 30, 40, 50, 60, 70, 80, 90. We've seen this. This is 9, but it's 90 because it's on the tens place. This is 900 because it's a hundreds place. If I look at it, this is how I do it, right? So this is the hundreds place. This is 900. And then we do this one. This is 9,000. Hey, Jasmine, thank you for the follow. And then this is 90,000. Z, you're with me? Are you still with me? Thank you for the hearts. Please, if you can, keep tapping the screen out. Oh, hey, Sashi. Thank you so much for the heart me. Does that make sense, Z? Are you teaching today or are you going to workshop more? I'm going to be teaching today, actually. It depends if there's any people that are, it depends if I'm going to workshop. So it's kind of a little bit of both, really. But I usually start off with teaching, and then later on, depending on how it is, then I'll start workshopping. Why? Did you want to workshop or did you want to teach? Did you want to learn? Because we can do... I didn't set it up. I didn't set it up my Canva, so we can't do Canva today. Anyways, I don't know if Z's still around. So when we count it, we're just going to look at the numbers, right? So if I did this number is, do you know what this number is? If I look at it, right? If this is 1, and these are the ones, these are the tens, and then this is hundreds, and this is thousands. What number do you think this is? Please put in the chat what number you think this is. Oh, Beal. 3,921. Hey, yeah, that's pretty good, right? But you've been here. Does it make sense? Is it all easy? Yeah, thank you, KJ. Yes, great. So let's do some more. Are we ready for some more? So we can do, so again, we're doing ones, tens, hundreds, thousands, 10,000. Thank you so much. Please, if you can, like my live, and if you can, please share it. Because what we're doing is we're counting right now. What we're going to do is we're going to learn how to read the abacus. Whoa. Okay, so we're going to count again. 1, 2, 3, 4, and then anytime the beads are touching the horizontal bar, this is considered counted. So we have 5. All the top bead has a value of 5 no matter what. The top bead, thank you, Bree. Thank you for sharing my live. This top bead is value of 5. So we have 5, 6, 7, 8, 9. After 9, we have 10. But look, it's very familiar, right? That looks very familiar if I did this. This would be ones. But the difference is that it's in a different column. These columns are place values. Each column is a place value. So we have our ones, our tens, our hundreds, our thousands, and our 10,000s. Does that make sense? So when we look, we have 1, we have 21, 31, 41, I'm sorry, not 41, 21, 321, 4,321, and then we have 54,321. Does that make sense? So when we look at it, let's do another number. Are we ready for another number? So here's another number. We do this, and then we do this. What number do you think that is? I'm not sure if Z's around anymore, but you might have left. Hello, China and Miss Hurricane K. Welcome, welcome, welcome. What we're doing is we're learning how to read the abacus. When we learn how to read the abacus, we can do adding, subtraction, multiplication, and division. But for right now, hey, S! I think we're going to go down some alphabets now. That's fantastic. It is, it is 1,700. 5, 6, 7. 10. Thank you for the follow, Ink Dragon writes. 5, 6, 7, 8. You're very close. You're very close. Yeah, right? Going down the alphabet. Yeah. We just need a. Thank you for the rose. So, S, I'm not sure if you saw that, but there's the top bead. The top bead has a value of, yes, Miss Hurricane, that's exactly what it is. Because the top bead has a value of 5. So we have 1,700, 5, 6, 7, 10, this is 10, so it'll be 18. 5, 6, 7, 8. Right? Make sense? Hey, Emmy, thank you for the share. Yes! Okay, cool. So should we do another one? Let's do another one. Okay, let's do another one. So we do this one with this, and then that with this. What number do you think that is? Thank you for the hearts. Wow, I already have almost 2,500. Wow, that's so. Thank you guys. Thank you guys for liking the live. Okay, so what number do you think this is? Please, if you can, it would be great if you could like the live. That's all I ask. Just like the live, and to know that I'm not the only one in the room. Oh, let's see. 4,359. We always forget the top beat. The top beat is not the lonely stepchild. Beals, yeah, right, Beal. 4,000, 1, 2, 3, 4, 300, 1, 2, 3, 50, and then 9. 5, 6, 7, 8, 9. We can't forget the top bead. The top bead is actually very critical. One of these, when we start working with the adding and subtracting, we'll understand how critical the top bead is, because we have to figure out how to utilize the top bead. But the first thing we're going to do is learn how to read. So I think we're okay how to read. So the next thing we're going to do is we're going to understand how to add. When we add, what we're doing is we're just moving the beads. We have 5 and then 4. That's what this is. That's what 9 is. So now we're going into, thank you, Miss Hurricane. Yes. So what we're going to do is we're going to go into some adding, and notice that when I created this book is focused on add-ins and not the result. So I notice in school, we want to always tell the kids, oh, let's make an 8. Let's figure out how to make an 8. But really what we need to do is focus on the add-ins. We need to focus in on the number. Thank you so much for the share, Beal. We need to focus on what we're adding. That is what's the story. Because we want to, it's, we care about the goal, but everybody's goal is the same, right? I'm hoping everybody's goal is to be happy, but how to get there is another story, right? And it's the same thing with adding. It's the same thing with math mimics life. It's kind of funny. So here is very specific. This is about adding the 1. When we add the 1, what do we do? All we need to do, so this one is 5. The picture is a 5, so I'm going to add the 5. And then what I'm going to do is I'm going to add the 1. When I add the 1, I'm only moving the 1 bead. I'm only moving the 1 bead. That's what we're focusing on. We're focusing on adding the 1 bead, because this is what's going to get critical when we start going into further, I guess, intermediate addition. But see, the funny thing is yeah, it'll be intermediate, because there are advanced adding and subtraction, not because the numbers are bigger, but it's how the numbers are working with each other, right? So does that make sense? Okay, so let's say we have 6, and I want to add the 1. So I have a question. I don't know if I have a question. I don't have a question. Anyways, so I have 6, and I want to add the 1. My answer is now easy, right? So what's my answer, if you can tell me? Tell me what my answer is. Put it in the chat, please. And then, hey, salami cheeks. So, what number is this? This is 5, 6, 7. Yes, thank you, Miss Hurricane. And Salami Cheeks, it says 34. So we do 30, and then this is 4, 34. Thank you, Beal. Right? So does that make sense? So the next thing we're going to do, since that was pretty easy, right? The next thing we're going to do is we're going to do adding the 2. And again, it's the same thing. The reason why the questions are simple for right now is because we want to make sure we understand what it looks like to add, what it looks like to move the beads and to recognize the numbers. So when I add the 5, I'm going to add the 5, I'm going to add 2, and I add 2. And my number is 7. So then if I had this one, which is 6, right, I add the 6, I'm going to do the 6, and then plus the 2, which is 8, right? Easy. So there was another, so that's the thing. And then we do it again. We do it again with the 3. But the 3 doesn't have as many questions. If you notice, there's not too many questions to add the 3. So it's like a 0, it's like a 1. So we have a 1 over here. So I'm going to do 1. And then I'll add a 3. And I'll add a 3. But then what happens when there's not enough beads to add? What? Well, that's when we have formulas. So what's going to happen is we have these formulas that we need to memorize. But the first thing we need to do is understand why we have these formulas. Well, in school, we're teaching the children, and this is a great concept. The great concept is we're teaching children how to make a 5. When we make a 5, so now we're getting to the part where we need to understand how to make a 5. We're going into like, how does abacus relate to mainstream math, like public school math or what have you, like anything, right? So good morning, Ethan. Good evening, Ethan. Fantastic mood. That's funny. Okay, so the first thing we're going to do is we're going to understand these are the concept. This is a concept that we're teaching the children. 4 plus 1 is equal to 5. Good evening. So you already had your dinner, right, Ethan? So then the other one we're doing is 1 plus 4 is equal to 5. We're doing this. Why? Because this is the commutative property, which means it's 808. It's 8 there, and I sat for, I'm happy. Mira, really? I sat for a math lesson. Yeah, this is a simple arithmetic math lesson. I hope you're okay with this. I really enjoy showing how to read the abacus. So, I don't know if you were around for this, but let's do some, do you know how to count, Mira? So we do 1, 2, 3, 4, and then all the top beat has a value of 5. So this is 5, 6, 5, 6, 7, 8, 9. So what we need to do is we need to understand how to read the abacus. When we read the abacus, then we can start going into adding and subtracting. Thank you so much for liking the lives, everybody. Thank you so much. So, yeah. And then if I want to do 10, the top bead is down when you add it from, yes. So the top bead, when it comes down to the horizontal bar, it comes down, it will be counted. But the bottom beads have to go up. So when the bottom bead goes up, now they're being counted. So we have 60. How do I know that this is 60? This is 60 because I have my little chart thingy. Let me have a chart thingy. Where's my little chart? I had a little chart that says ones, tens, hundreds. And I lost it. So, what am I trying to do? I'm trying to show you where my ones, tens, hundreds are. So these are my ones. These are my tens. And then this is the hundreds, the thousands, and then this is the 10,000. Okay, put it in here. Did I put it in here? No, I didn't put it in here. Oh, here it is. I found it. So, we're talking about place values. So, on the abacus, we actually have place values. Can you see that? When we look at it, every column is a place value. We have our ones, our tens, our hundreds, our thousands, our 10,000s. Now notice there's a decimal. Because there's a decimal, notice the decimal doesn't fall on a place value. What it falls is between the two columns. So we have our ones, our tenths, and our hundreds. But the numbers are exactly the same. So if I have 6 here, this is 6. But now this is 66. Welcome, Jasmine. Does that make sense, Myra? So then when we look at it, this is 66 because it's a 6 and a 6. So 66. This would be 76. This is 86. This is 96. And then this is 106. 106. So if I did this, this would be 100. 200, 300, 400. So notice this is exactly the same as this. It just depends on what column we're in. I'm a nurse. I would look so cool doing, yeah, yeah, you would be. So that's how we read the abacus. And now what we're doing is we're understanding the concept of adding the 5. The reason why we're learning how to the adding of a 5 is, one, the school is teaching crazy things. No, it's not crazy. It's actually a really concrete fundamental thing. So this is what the kids are learning. 3 plus 2 is equal to 5. And then 2 plus 3 is equal to 5. Now why? Why do we need to learn this? Well, the first thing we're going to do is we're going to isolate the variable. Remember in algebra when you isolated the variable? If I change this equation to say x plus 1 is equal to 5, right? What we want to do is we want to isolate the variable. When we isolate, my daughter's school is teaching Common Core and I hate it. You know, oh, but if she knew abacus, she would enjoy it. Because abacus, this Common Core stuff, it really relates to abacus. My kids, actually, I have 3 boys, and they all know how to do abacus, and they had no problems with Common Core because a lot of the big concepts, really kind of boils down to abacus. And what abacus does is it gives it into more manageable chunks. So, because you don't understand, Common Core is used everywhere. Well, yeah, Common Core is used everywhere, but it's also how it's presented too, right? So if it's presented, it gets kind of confusing because there's a lot of pictures and they do a lot of like conceptual things where it doesn't translate to what we're doing. So if there's an Abacus in school, I'll be joining you immediately. Ethan. Okay, so we're back to here. What we're going to do is we're going to isolate the variable. So when we isolate the variable, I'm saying it like this because we're all adults, and I wanted to show how it relates to mainstream math. So the first thing we're going to do is we're going to isolate the variable. We have 5 minus 1. So if I replace my x to a 4, I do 5, right? Does it look very familiar? So the next thing I'm going to do is I'm going to show you a question. I have this question. 3 minus 4. I'm sorry, 3 plus 4. Well, notice, thank you so much for the follow. So when we do 3, we have the 3. Not a problem, right? But the question is now I have a 4. I don't have enough beats to add the 4. So what am I going to do? Wait a minute. This is a core concept. Thank you for the follow, Dardis. Thank you for the follow. Thank you for the likes. Okay, so what's going to happen is we know this concept. Why? Because it's this 5. We're going to make our numbers work for us. We're not going to have some lazy ass numbers. What we're going to do is we're going to make it work for us. Why? Because we cannot break the 5, but the 5 is very useful. We want to add the 5, but notice 5 is too much because what we want to do is plus the 4. So if we add the 5, it's too much. So we have to take away the 1. So my answer is 7. It seems a little complicated now, but this actually scales to larger numbers. So this can go to like bigger numbers like 70. But when we talk about 70, we don't say plus the 50 minus the 10. We don't say that. We break it down to its manageable chunks. Thank you so much for the hearts. Thank you so much. And the heart me. Thank you so much. I appreciate that. So does that make sense? What this means is we are utilizing what we're learning in school, which is how to make a 5. And it's great. But what the Abacus is, we supercharge it. Oh, I have to write my supercharge. I have to figure out, I got to get a better way of writing out my lightning bolt. That's what I'm trying to do. That's what a lightning bolt is. So we're trying to supercharge our numbers. We're going to make our numbers work so it works for us, right? So we know this concept. And again, we have a plus. If we did a plus, we can do a minus. So we know this answer. This answer is 7. This answer is 7. So we have 7. So now what if we did minus the 4? Let's do the reverse. We don't memorize doubles. What we memorize is our elements. We memorize our formulas. We memorize the stuff that makes sense. We memorize stuff that's more versatile. So because we know how to make a 4, we want to add the 4, there's the opposite, which is the inverse. So it's minus the 4 is equal to minus the 5 plus the 1. So how does that work? Well, if I do this and I want to take away the 4, I can't take away the 4. Notice I build on top of each other. I know the concept of 4 is equal to 5, right? Minus the 1. Then I just do the reverse. I do the opposite. I take away the 5 and I add the 1. Does that make sense? Put it put it in the chat. Your track, no, was it HB, because we're a horizontal bar. We're tracking. We're tracking the numbers. We're tracking the concept. So this might seem, it's I'm just going back. Thank you, Ethan. I'm just going back to some of the comments that I had earlier saying that this is really complicated. It's like, no, it's not complicated. I really don't understand. I'm new. Not a problem. Hey, Polly Lee. Hey, Sasha. Okay, so we're going to count again just so we can review, right? We're going to review. I got a little lost, but I'm going to keep going. Okay, no. Start over. I'll start over. Let's start over. It makes sense, not just to grow up with. Yeah, I didn't grow up with this either. I actually learned this like afterwards, but I live vicariously through my children, and they all know it. I'm a little upset, but I'm happy that they know it. Okay, let's start over. So we have 1. Every time this horizontal bar, every time the beads are touching the horizontal bar, this is 1. So all the bottom beads, this is a bottom bead, it has a value of 1. So this is 2, 3, 4. We're okay? We're tracking like a HB? HB, like a horizontal bar, like GPS. So this horizontal bar tracks our number. That's all it does. It only tracks our number. So all of these columns are 0. These columns are all 0. This one's the only one that's being tracked, right? Tracking. Yes, right? So the top bead will always have a value of 5. So when I bring it down, this is touching the horizontal bar. Now we're tracking. We're tracking that this is 5. Because this is 5, we can count higher now. How do we know? Well, remember that this is 1. We know 5 plus 1 is 6. So we can count on. This is a concept. Oh, Mira, how old is your child? So this is 5, 6, and this is 7. So after 7, we have 8. We're just adding, right? 6. Oh, maybe the abacus would be perfect. You learn how to do the abacus, you could teach your child how to do the abacus. So we have 5, 6, 7, 8, and then 9. We have 9. Notice I can do the same thing. After 9 is 10. We saw this before. So now we're looking very common. We're just building our concept. We're building. We know this is 1 because this is 1. So if that's 1, this is 1. If that's 1, this is 1. They're all 1s. So if I did this, right, these are all 1s. Well, why? Well, what's the difference between them? It's all about the place value. So every column is a place value. Just like this. I have my 1s, my 10s, my 100s, my 1000s, my 10,000. So when I look, I do 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Easy, right? We just gotta review how to read, because I go through a concept and then I go back. So the question is what's after 9? 10. We saw this. We've seen this before, just over here, but now we're in a different place value. So we have our 1 and a 0. So just as we write 1 and a 0, this is 10. Make sense? Easy, right? Thank you, Jasmine, for following. So we do 10. We can do 10, 20, 30. Oh my God, I'm counting by 20s. I'm sorry, counting by 10s. 30, 40, and then 50. We have 60, 70, 80, 90. Every column has a 9. Doesn't matter. You can't go higher than 9. It's just like writing. Right? When we do 1, 2, 3, 4, 5, 6, 7, 8, 9. What's after 9? Well, we have another column. Same thing. Abacus mimics the way we write. Right? Sloozy. How do you multiply? We can multiply on the abacus, but not right now. It's beautifully elegant. Yes, it's crazy how simply elegant this is. Things make sense. Not a problem. I'm so happy you commented, because if you never commented, I wouldn't know where everybody is, right? It would make sense, but if you guys all commented, then I can just always go back, because it's super easy to count. So this would be, what number would this be? What number would this be? Hey, David the Crockett's. That's funny. Dardis, does that make sense? 5. 5. 900. Yes! It'd be 900. So, bald-headed bug, yes. Haven't slept and now I'm learning abacus. Good night. Good night, Sloozy. Yes, this is 900. So, somebody came in. Somebody came in and said it was 5. Oh, bald-headed. Bald-headed. What we're going to do is we're going to count. 1, 2, 3, 4. Hi, Troll Keeper. Hopefully you're not... Oh, Troll Keeper. I hope you're keeping the trolls for me. So we have 1, 2, 3, 4. This is 4. Anytime the beads are touching the horizontal bar, this is 4. I'm sorry. Anytime the horizontal beads are... Anytime the beads are touching the horizontal bar, it's being counted. Sorry. I had to read that a few times. So, because this is 4, it's touching the horizontal bar. None of these columns are touching. That means that these are 0. Where do you purchase it? You can get it from my link in bio. Yeah. But this one is 7 columns. There are other columns, just so you know. And it depends on like how old you want to go. So if it's just for you, I would recommend going to Daiso to go to get a 13 column one. But if your child is young, if a child is young and you're teaching a child, I would get the 7 one and the colorful one because it's kind of pretty. And it's also colorful, and I think the kids like the colors. So, Troll Keeper, we have 1, 2, 3, 4. This is counted. Because this is the horizontal bar, this is counted. Do you do 15? How do you do 15 take away 7? We will get to that in a little bit, but I will write it down. So, Troll Keeper, the top bead will always be 5, no matter what. So, 15 minus 7. All right. So, does that make sense? Yeah, the colors are helpful. The colors are helpful when I teach online, just because it's easy to see how the beads move. But sometimes the colors can be overwhelming, depending on the child, depending on the person. So you could get a 13 column one. A 13 column is also nice after the fact, because if they start from here with the colors, then they can graduate to bigger numbers. And that's what the 13 is only. They work exactly the same. So for Troll Keeper, we're going to count 1, 2, 3, 4. And then the top bead is 5. These, all the abacus feels this, all the abacus works the same. So after 5, we have 6, 7, 8, 9. Notice there's 9 here, there's 9 here. These two are 99. Now, how do I know that they're 99? Because now I talk about the place values. Every column is a place value. Ones, tens, 100,000, 10,000, 100,000, and then this one's a 10 million. Now, the reason why I start here in the middle is because I have a dot indicator. I have a dot indicator. This indicator tells me where the ones place. I'm not sure if Troll Keeper is still here. So that's why I start over here, because I have an indicator. This indicator I use as my ones. You could use this one, or, oh good, you're still here. So your number is 1, 2, 3, right? 123, we'll do 123. Does that make sense? Are we all right? That's how it's read. That's it. So when we add, so 13 gives you 6 decimals in the increment. Oh my goodness. So 13 gives you, it can go more actually. The whole 6 whole numbers increments up to tens. Yes, yes. Do you do negatives on the abacus? No, we don't do negatives on the abacus. Oh yeah, bald-headed bug, right? Okay. So, actually, Mira, it depends on what it depends on what indicator you want to use. You could do the one in the middle. Then you have a million, right? Ones, thousands, millions. Or if I wanted to, hey Robocop, I'm getting it now. Good. You could start here, just like a Pokemon, right? I choose this dot. This is the dot I choose. Then this is the dot would be my ones. So it'd be my ones, my thousands, my millions, my billions, and my trillions. So it all depends. It's not the decimal point. This is a dot indicator. The decimal happens between the indicator and the tenth, right? The decimal does not have a place value. So we have to be careful with the verbiage. right? So with the way we're talking about the decimal, yeah, it just depends on where. It's all about perspective of life. So let's say we want to track. If you want to track the national debt, you would need a bigger abacus. This is 23 columns. So the 23 column, you can track the national debt. The dot is like a, yes, the dot's like a comma. Exactly. The dot's like a comma. And then these are the separators, just like the 1,000 commas, right? Big facts. So the dot is not a decimal. Correct. The dot's just a place. No, the dot is an indicator. It's just an indicator. It just tells me where. It just tells me where I want to start my home. That's it. I want my home here, or I want my home over here, or I want my home. I love that the yeah. So I get a little corny. I'm happy you guys like my corniness. So there's a couple of people that enjoyed the whole Pokemon comment as well. Okay, so we're okay. We're tracking. Are we tracking like a horizontal bar? Okay. So the first thing. So what are we gonna do? We're gonna continue. I gotta go. Okay. See you later. Hopefully, I'll see you in my next live. This is the most fun I've ever had. Yeah, right, Mira? This makes my day. Oh, Bill, thank you so much. I was actually kind of like, I don't know if I should go in morning, but I'm like, let's do it. I thank you guys so much. Thank you guys so much. Tracking, right? Like a horizontal bar or GPS. I don't know what you want to use. So let me go back to my other one. So we're back to, this is 100% been the best life I've been in a while. Oh, thank you, 500 miles. 500 miles. Look, 500 miles. Let's do 500 miles. 500. 005. That's it. Dr. Architect. I've always wanted to learn how to use this. I love this so much. It's much simpler than that. Yeah, right? It is. It's simple to use and easy to understand. Let's get into some formulas. So these formulas, again, is about understanding concepts, right? So we know how to read the abacus. That's great. But there's more to it. There's more to abacus than just reading, right? What it is there's an abacus method to doing adding, subtraction, multiply, and divide. Do you do multiply? Yes, you can. Oh, I had a question right here. The question is this one. This one gets a little complicated because it depends on whether or not we have to do, let's see, yeah. It depends on what we're going to do. So yes, we can multiply in a little bit. We can actually multiply, divide, and subtract. Multiply, divide. But the first thing we're going to do is we're going to understand how to do this. There's a few concepts that we need to understand. One of the concepts is how to make a 10. So let's make a different color. So I'm going to use a different color. I'm going to use purple. So there's a concept that we need to understand, how to make a 10. That's another thing that the kids are learning. The kids are learning these days. So we do how to make a 10 is 7 plus 3 is equal to 10. This is something that we need to know. Why? Because we're going to start utilizing the next column. That's what this is. Fairy Mary on the Tinkerbell. Yes! Yes, Fairy Mary. I did look that one up. Fairy Mary, and I got to go back to make sure that's what it was. Her abacus was actually horizontal, I believe. And her abacus was a 10 bead, I believe. Or it could have been a Chinese one. So this abacus is a Japanese abacus. Japanese abacus. There is a Chinese abacus. This is a Chinese abacus. It works relatively the same. Now we know what to say. Yeah. Yeah, right? So this is a Chinese abacus. This is a soroban. So let me write the, okay. So this one is a soroban. Soroban. This one is a suapan. This is a Chinese abacus, and then this is a Japanese abacus. Chinese feels more complicated to me. It is a little bit more redundant. It is a little bit more redundant. So that's the difference between the two. Let me see if I can do that. Can I do this? All right. All right. So what are we going to do? Let's do a review. Let's do a review. So we're going to review. Let's see. Okay, we got that. All right. It's the same. It works exactly the same. It's got the 5 beats on the top. So 1, 2, 3, 4, 5, right? Easy, easy, easy. And then we do 5. Notice if I do 5, we have to trade it. We have to trade in the 5. 1, 2, 3, 4, 5. We have to trade. This 5 will be this 5. That's all the thing is you got to continue to trade. Where on the soroban, on the Japanese abacus, you don't need to, because this will always be 5, 5, and 5 only, right? So then we have 5, and then 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, and then this is 10. This is 10, this is 5, so we trade. So we trade this one for the top bead. And then we have to trade these two for one over here. The reason why is because this 10 doesn't make sense. It's no longer a place value. So it breaks the concept. So what they need to do is they need to trade it, and that's what happens. There's a lot of trading, but it works exactly the same. You got to still do the formulas, and that's what we're going to talk about right now. But that's the difference between the two. There's a lot of trading, so there's extra steps. When did this happen? Well, Japanese happened before the soroban, but the soroban, I think the bigger one makes it it's a little bit redundant. The soroban, actually, what Japanese people do is they make everything efficient. So they made the abacus efficient, and that's what we ended up with. So a lot of people in the other parts of the world actually uses this one. There is no Chinese abacus competitions, but there's a bunch of Japanese abacus competitions. There's a lot of competitions that happen, and they're all based on here. There's a lot of videos. If you notice that the videos of the abacus, they're all based on this one. But in the Chinese one, it gives you the ability to look at the place to check yourself. I think the soroban formula, the Japanese does that as well. The Japanese, the one you can always go back and check yourself. The Chinese one is just more complicated. It can get kind of unruly. So, but the Chinese one was meant for not meant. The Chinese one was just it was just before. How would the competition work? If you just be faster, and you have to practice a lot. I don't practice too much, and I'm not in it. But that's what it is, and it just go through a lot of the questions. You have to go through a lot of questions. So like, it wouldn't be easy questions like this, but you would have to go through like a lot of these questions, and you just kind of pound it through. So I feel like the Chinese one would be harder because you have to remember. Yes, exactly. Instead of basically doing yes, exactly. And that's where the trading in has to happen, because like you would have to remember, if I did this, this is not 55. This is 110. So I would have to remember to make that this is 110. You know what I mean? So I have to do, 10 trade and then 10 trade. So they gave you a double-sided paper. It gives you to add, subtract, to finish the first time, I think. What? I'm sorry. The Japanese one are efficient, carry use as long as you know how to use it. Yeah. Yes. The Japanese. Okay, so we're back to here. What we're doing here is we need to understand how to make a 10. So because we know how to make a 10, we're going to isolate the variable. This is the variable we're going to isolate because we want to add the 7. So it's 7 is equal to plus the 10 minus the 3. Are we okay with that? I was answering how competition works. Yeah. Yeah. They give you a piece of paper. Yeah, they give you a whole piece of paper. Yeah, but sometimes they project it on the screen, and it does like flash ends on, which is just a bunch of numbers that flashes, and then you have to add it and subtract. I don't think they do division. I think division's a little bit harder. I think a lot of the questions are adding and subtracting. So the numbers get big. So right now I'm doing really. They do paper and flash too. Yeah, I think they do paper and flash as well. They might do hearing, but I'm not sure. I'm not sure if they do hearing. I hate to leave. Oh yeah, not a problem. Wish me luck, guys. Yeah, good luck. Good luck. Hope to see you in my next lives. I hope your child will get to learn how to use the abacus. All right, so this is what we're doing. So we're adding 15. We add 15. Now the question is to add 15, and we want to add 7. But notice there's not enough beats to add the 7. I hate to leave. Yeah. Not a problem. So we have to add the 7. Now the problem is this is a two-step. This is a two-step equation. How do I know? Because I don't have enough beads to take away the 3. So what I'm going to do is I'm going to add the 10. So I'm going to add the 10. So this is what I got to do. Let's see if this works. I was trying to make something. So what we're going to do is we're going to add the 10. That's what we need to do. We're going to add the 10, but we have to take away the 3. Do you see how I have to take away the 3? Is there a 3-step or more equation? Yes, there is. And that's when we start doing, there's a lot. Yeah. Well, when the 3-step, it's like, if you, yeah, we can do 3-step more than 3. That's when we start doing like 4,000 take away 3, right? Those are more than 3 steps. So what I want to do is I want to plus the 10 and then take away the 3. Notice I want to add the 1 here. That's what I want to do because I want to add 7. So because I'm adding 7, I have to plus the 10, take away the 3. Is that the token you were working on shopping the other day? Yes. You know what? This is the flippy thingy. Yeah. So I finally made the other ones and I had that up. I finally put it up and I had proper ones. The one that I did was the token thingy was this one, where I made this one. And I made it vertical. So the reason why I made it vertical so we can be reminded if we're going to add or subtract. So the first thing we're going to do is we're going to plus the 1, right? We plus the 10, right? Does that make sense? Because every column, so when I plus the 10 minus the 3, so now this column I have to take away the 3, but I cannot take away the 3, so I have to minus the 5 plus the 2. So when I minus the 5, right, I have to minus the 5. Here's my little reminder, my minus the 5, and I add the 2. Notice, imagine that there's an imaginary line here. I didn't want to put the line here because I didn't want to look like it was a fraction. But if you notice, if you line it up, I want to take away the 5 and I want to add the 2. Right? Now, why did I do that? Because I need to add the 7. Right? And I needed to minus the 3. We know how to minus the 3 from the previous question. The previous concept was this, plus the 3. If I changed it, right, if I isolated my variable, it's 3 is equal to plus the 5 minus the 2. And then I have to do the reverse, right? So it's minus 3 equals minus 5 plus 2. So this is the concept, but we were jumping. So just so you know, this concept, doing this is a 2-digit question, and that happens later after you understand how to add the 5, take away the 5, add the 10, take away the 10, if that makes sense. So yeah, we could do 400, but that's what happens, right? I mean, I have a whole curriculum, but have a good day. Thank you for sharing your time. Yeah, no, thank you for joining. I hope it made sense. I hope to see you in my next live, and we can continue on to learning how to add, subtract, multiply, and divide. Thank you for the heart me, Bill. Okay, so, oh, that was the question. The question was 400. So 400 take away 7. So we do 400 take away 7. It's still the same thing, right? But it's just a bunch of numbers that the bunch of equations that we're dealing with. So we do 400, right? We do 400, take away 400, right? I don't completely understand all of this. It's cool because I'm not good at math, but you're very good at explaining, by the way. Oh, thank you. It's cool. It's not a problem. It depends on how we answer the read the abacus before we go through. Okay, so Ethan, hold on just a little bit. Is cool 556. What we're going to do is let's learn how to read the abacus. Are you okay with reading the abacus? Just so I can figure out where everything is. Because when we look, it's 1, 2, 3, 4, and then we have a value of 5. Because the value of 5, we have the value of 5. How do I know? Because the 5 is touching the horizontal bar. When the 5 touches the horizontal bar, it's being tracked. So we have 5, 6, 7, 8, 9. After 9, we have 10. Notice that this 10 looks very similar to this. It just depends on the place value. Every column is a place value. So when we look at it, these are my place values. If you remember in our numbers, we have our ones, our tens, hundreds, thousands, 10,000. So here is 1, this is 1, but now this is 10. And now I can count by tens. 10, 20, 30, 40. Notice it's exactly the same as this, but in a different column. When we do 40, we do 50. Again, the 5 is the top. Yeah, not a problem, Distus. Dr. Tis. I think it's Dr. Tis. Yeah. Thank you. I hope to see you in my next live. Okay. Dartist. That's what it was. Dartist. Okay. So. Is cool. Did that make sense? Oh. DDR test. Got it. Got it. Is cool. Okay, good. So we have 5. So like for your number, you have 556. So it'd be 556. Make sense? So just as we have our numbers, 556, we have our hundreds, our tens, our ones. And then here it sits between my decimal. My decimal doesn't sit on a place value. Thank you so much for the heart puff, DDR. The decimal sits between the columns. It doesn't sit on a place value. So we have our ones and then our tenths and then our hundreds. Great. So then we can count. And then we start going into formulas. So after we learn how to after we learn how to read the abacus, we'll start doing some adding. So when we add, we actually showed some simple addition, which is here. We do 5 plus 2 is 7. And then we do 7 plus 2. I want to add 2 beads plus 2. All I got to do is just add these 2 beads. And then I have, thank you for the follow. Then I have 9. So then I have 9. What if I want to take away? All I got to do is take away 5, move the top bead up, and then I have I'm left over with 4. Thank you for the follow. Hey, it's April Ann. Thank you for the follow, April Ann. Does that make sense? It's cool. So what we're doing is we're moving the beads, but notice that there's no formulas. Now the question is what happens when there's not enough beads? Like this one. So if I did 2 plus 4. If I did 2 plus 4. Oh, excuse me. I'm trying to find my 2. Okay, good. There we go. Yes, I've always seemed confused these days, but this really helps. Yeah, not a problem. So the question is if I had 2. I'm sorry, that's not the right one. I want to do 2 plus 4. There we go. I want to do this one. So we have the question 2 plus 4. Notice I don't have enough beads to add 4. Right? I don't have enough beads to add 4. So then what I have to do is I have to start going into some formulas. The formulas we have to talk about is understanding how to make a 5. So in school, we're teaching children how to make a 5. So that's what we're doing. We're trying to make a 5. What we're going to do is we're going to isolate the 4. Why? Why are we going to isolate the 4? Because that's the question we have. We want to add the 4. There's not enough beads to add the 4. So we got to figure out something. We want to utilize our 5. We want to make our numbers work for us, right? We want to make our numbers work. We don't want them to be just sitting around freeloading off of us. We want to make them work. So to make them work, what I want to do is I want to isolate the variable, and I'm going to make 4 is equal to adding the 5, and you take away the 1. So if you notice, when I even write it, right, I want to write 4 equals to 5. This is too much. So how do we balance the equation? We balance the equation by taking away the 1. How does this help? This is where this comes into play. So what's going to happen is I need to add the 5. Remember, adding the 5 is too much, so I have to take away the 1. So that's what we do, is we plus the 4 is equal to plus the 5 minus 1. And my answer is now 6. So I can write 6 here. These are formulas that we need to know. We need to know these formulas because it gets to this, right? Yes, exactly. This is algebra flashbacks, right? Easy, right? This is algebra. This is the beginning parts of algebra. When you understand abacus, it's a gateway to complex math. It's exactly what it is. Because look what we just did. We substituted this equation, this formula, into the 4. That's what we did. We substituted and then we isolated. Makes sense, right? 500 miles? So just as we did here, we substituted 5 minus 1 is equal to 4. I didn't learn this in high school. No, sorry. My kids learned it when they were young, but that's only because I lived through them. Can you explain how it's a gateway to complex math? It's a gateway to complex math because there's a formula, there's a set formula, there's a set framework in Abacus that you have to start thinking about. So what Abacus does, we have conversations with our numbers. Would this have made, yes, right? This would have made math so much easier at school. I know. That's what I'm saying. I live vicariously through my kids. My kids breezed through elementary school because it was just so easy for them. This clicked so much in my brain because my kids explained it this well. Oh, really? Thank you. Thank you. I appreciate it. Thank you. Thank you. Yeah, it's just one of those things. But see, the thing is we have to in Abacus we have a conversation with our numbers. So we always have to ask why. Not why. No, how. How can I do this? So if I have 3, how can I add 4? I cannot add 4. How can I add 4? How can I add 4? We've done it. We just have to go back to our formula plus the 5 minus the 1. So I add the 5 and I take away the 1. You'll notice that there will be a pattern. This is a number pattern that you'll see. I want to add the 5, take away the 1. And then what's going to happen is when I minus, it's the same but just the opposite. Minus the 5, add the 1. Yeah, because vocabulary is people pretty much forget Abacus and people rely on calculators. It's a little much. Are you a teacher by day? You're the best teacher. You make things make sense so quickly. I am not actually a teacher by day. I'm trying to do it. I've been an Abacus teacher for about 20 years. I enjoy making things simple because we need to strip away complexities. Before I got laid off, my job was a computer programmer. But now I got my laid off and then I'm like, you know what? I'm going to try doing this Abacus and see if I can take it off. Because I really enjoy Abacus and I think it needs to be part of the world. And I've been teaching Abacus for about 20 years. When they want people to remember math, it doesn't stick. You know, the interesting thing is that they push all the kids to do this in their head. Whereas Abacus, it grows with you all the way to adding multiplication and division. You know what? Even the old Chinese people, as old as the Chinese abacus is, even the old Chinese people still use the abacus. They don't do it in their head. So I don't know why there's a rush to learn everything in their head. No, I understand. Troll keeper, I understand. But thank you for keeping the trolls. Yeah. I appreciate that. Thank you so much. I appreciate that. Yeah, I try to make it, but see that's the thing, right? Like the idea was try to inform people about abacus so much so that when you have children or whatever, you teach children or however, you can teach them abacus. Okay. So, now the reason why this one was a little bit more complex was because this is a 2-step equation. Ethan wants to push the whole class forward and see if we can do a 3-step equation. So, we know how to do a 5. We understand how to make a 5. We understand kind of how to make a 10. Well, there's the reverse of this, right? We know that if we want to make a 10, 7 plus 3 is equal to 10. We know when we isolate the variable, we do 7 is equal to plus the 10 minus the 3. So when I rewrite it, I don't know if Beal is, oh, you're still here, Beal? When I rewrite it, I do plus the 7. Beal is so quiet. This could have helped me a lot. Oh, there you go. Oh, really? This would have helped me. Does it help you? I've always wondered about dysgraphia. Oh, there it is. Hold on. I have not met people who had dysgraphia and dyscalculia until I came onto TikTok. And it's interesting because the kids that came through my school, the learning center, the kids that came through my learning center, they were on the spectrum. So I never really met anybody, and I've always wondered if this would help. So that's why I have like these little tool thingies. So, oh no, that's the wrong one. Oh, I gotta go this way. Yeah. No. There it is. There it is. So if I rearrange it to be vertical, I have plus the 7 is equal to plus the 10 minus the 3. So if I made it vertical, plus the 10 minus the 3. Kind of like not being able to render all the parts, I think. I don't know. I don't know. So what we want to do is, if you look at this graph, if you look at this, I made it vertical because if you look, 10 is right here. There's a 0 and a 1 here. So when we want to add the 7, so let's do this 9 plus 7. When we want to add 7, we want to take away the 10. I'm sorry, we want to add the 10. Oh, that's not right. We want to add the 10, but here we want to take away the 3. So we're going to take away the 3. Does that make sense? So my answer is 16. I kind of like it. All right. So this is what we're doing. We understand how to do this. We understand how to do this. So what's the opposite? What's the opposite? Minus the 7 is equal to minus the 10 plus the 3. That is, I'm still confused, really. Actually. Oh, with the formulas, 500. It just turned on. Ah, the inverse formula? No, no, no. Yeah, I don't know. Okay, so, okay, got it. In school, we're teaching the children how to make a 10, right? So let's go back. Let's go back. Hello, Mira. Let's go back a little bit and let's go make a 10. What ways with 2 digits, how do we make a 10? How do we make a 10? What are the 2 ways to make a 10? I'll give you a hint. 5 plus 5 is equal to 10. I did the easy one. Give me another 2 numbers to make a 10. But we just go through this. So it all depends about going through, like, understanding. Thank you for the heart. Thank you for the finger heart. Okay, 6 plus 4. Okay, we got 6 plus 4. What else do we have? Great. No, that makes a 9. Is cool. 8 plus, yes, 8 plus 2. And then Keeper does 4 plus 6. I don't know who you are. Yes, 7 plus 3. So we did 7 plus 3. I think we're done, right? We're done, right? Oh, yeah. You're right. April, thank you. Thank you, Natalie. We got one. One more. Yes. So, and then we have the inverse, right? We have this way. So now, what we're going to do is, if you notice, we'll understand what the, oh, that was a battle. Somebody wanted to battle me. Ah, that's okay. So what we want to do is we want to pay attention to these partners. These are all partners. Why are they partners? Because this is how another way to make a 10. What's going to happen is, if I isolated, let's do, can we do 9? We'll do 9. Is that okay? We'll do 9. So if we isolate the 9, what we're going to do, what does that mean? We take this 1 and we move it to the other side of the equation. So I'm going to have plus the 9 is equal to plus the 10 minus 1. So if I did this, 9 is equal to plus 10. Not plus the 9. I want to add the 9. Notice that adding a 10 is too much. So what do we have to do? We have to take away 1. So now they're equal. It's no longer 6, 7. Right? Now they're equal. So what I just did is I just rearrange this concept. 21. No, not 21. Why? It just finally clicked why we subtract. I never understood that. Yeah. Okay, good. Yeah. So what it is I'm moving the stuff around because we know this, but I'm just moving this. Yeah, right? Huh. This is why it's. Yeah. So because I bypassed it. I don't know how. Sometimes I talk a little fast, so I bypassed a few things. But the thing is to understand. Let's do another one, right? We can do another one, right? We want to do this one. If I want to add the 1 and I said I want to make a 10, how do I make these equal? Right? How do I make it equal? Because it's an equal sign. We have to make it equal somehow. To make it equal, I have to take away the 9. Yes, thank you 500 miles. Thank you, Tony. Hi, Tony. Hi, Tony. Okay. Yes. Make sense? So what we do is when we isolate the variable, this is the number I want to use, and I'm going to use it with something. I'm going to use it with a 10. That's what I'm going to do. Then how do I make it? How do I balance it? Yeah, not a problem. I'm happy you made a comment, because if you don't make a comment, I don't know, right? The squeaky wheel gets the oil. I don't know if you guys know that. That's a very old terminology. Squeaky wheel gets the oil. I need to know, right? I need to know so there's feedback, because I don't want to be the only one in the room and I'm just going to be talking and then be like everybody's like, oh, I don't know what's going on. Okay. So we're back to here. If we know how to take away, if we know how to add, we're going to know how to take away. Right? So if I'm going to do the opposite, the inverse, the reverse, opposite, I'm going to do the opposite. Minus the 1 equals to minus the 10 plus the 9. Notice they're very similar. This is now, I don't know if anybody knows math terminology, but I just found out that this is called cumulative. Nope, that's not it. Nope, that's not it. That's not it. This is just inverse. This is inverse. Yeah, that's inverse. I don't really ask questions in school because I don't like to, but this really did help. But it's cool. You need to ask questions, because if you don't ask questions, nobody's going to know what you're confused about, right? You have to ask the questions. If you don't ask the questions, you're not going to do anything in your life. You got to ask the question. You got to be the brave one to say, huh? You have to be the brave one. I'm like that in work, in my other work, and I'd be like, so you're telling me that we need to do it this way, or do we need to do it that way? And I'm the first one. You know why? Because somebody else will have the same question. If somebody else has the same question, or somebody else can explain it better than me, which is fine too, right? That's probably why I was confused before. Yeah, I have to always ask the questions. There's no harm in asking questions, right? You should always ask questions. And you know what? If they are offended with the question, then that's not a person you want to talk with. I'm just saying, right? I mean, I get people telling me that they don't understand, which is fine, but then they're like, "Well, how does this work?" Well, I just answered them. That's all. My teacher told us to ask questions, so my friend went up to her. She said, we were supposed to know. Ah, Liz, I hate asking because the social anxiety or something. Yeah. See, that's too bad. But see, if you knew, it's okay. I don't know about your teacher. But I would be like, if we did this for a whole month, you should know that. You know what I mean? But it also depends on how it clicks. So, what did you do today? I learned math on TikTok by choice. Yep. Just repeat it back to you. So, I I always try to find different ways to explain. But I feel sorry for the teacher, the person that, you ask and you don't get. But in this room, you need to ask, because I don't want to be the only one in my room. Thinking and telling your friends about this later. Yeah. Okay, we did it for class 1. Yeah, okay. So do we understand the negative? We understand the inverse? Bro, exactly. It never helps. Yeah, sometimes it doesn't help. So, does this make sense? The inverse? Okay, good. So what we're gonna do is we're gonna push Ethan decided to push the whole class forward, and we're gonna do something called the two-step. Two-step just means we're gonna do more than just one step. The question is 400. So I have 400. I'm gonna have 400. So I have 400, right? We have 400. 400. And now we need to take away the 7. Barely, but yes. It'll be good. It'll be good. You know what it is? All it is just practice, right? It's about practice because I'm giving you a lot of information. Usually this happens, in a couple of weeks. So Troll Keeper, just so you know, like this, what I do is that when I teach my students, they learn this. I mean, my students are young, so it takes them about a month or 2 months to understand this concept, right? But for you guys, it'd probably take you about a couple of weeks to understand the concept because we would go through questions after questions after questions. And then we would do the plus 10 and do the same thing, question after question after question. And that's what the books are for. I've been telling everyone I know about the Abacus since oh yeah! Thank you so much, Bill. So the difference is in Abacus and mainstream math is we focus on specific questions. So there was a person that was asking about it. It's like, well, is there going to be answers? There's answers to the books. You could cheat, but there are answers to the book. And the way I have it is every question is very specific. So here, let's do this maze. So if we do this maze, the question is 3 plus 3. Again, if you notice, this is building on what we know in this book. This book is only talking about the plus 5. Does that mean? That means we're only going to be working on this stuff. That's it. We don't go anything more than that. Why does it need to be specific? It needs to be specific because you don't want to be confused. They build on each other. Hey, Mr. Clean, welcome back. They build on top of each other, right? You like this. So if we had a question like this one, if we had this question, we don't know how to do it. I feel like I would be confused. Oh my God, Lynette. Yes. Hi, Mr. Clean. Yeah. See, that's what it is, right? Because in mainstream school, in mainstream math, we just give you a bunch of numbers and you just figure it out. But in Abacus, there's a framework. You learn. There's a framework to everything. There's number patterns to math. And Abacus shows you that there's number patterns. So if you notice, the first thing we do is we understand how to just add. And then this is it. That's all we're doing. We're just understanding how to add. So this question here is 5. So I have the 5 and I add the 3. I add the 3. I didn't do anything. I didn't add any. There was no formulas. The next one is this one, is what we were just talking about, right? Is adding the 5, right? We don't memorize doubles because it's a one-hit wonder. I don't know if you guys know that terminology, but it's a very old terminology. It's a one-hit wonder. Why is doubles a one-hit wonder? Because you can only add. You can't subtract doubles. Subtracting doubles is just 0. It doesn't matter, right? And then there's strategies. Well, if you know doubles plus 1, doubles minus 1, whatever. We don't memorize doubles. What we do memorize is the core, which is this. We did this before, right? Plus the 4 is equal to plus the 5 minus the 1. So if we do 2 plus 4, if we do 2 plus 4, we do plus the 5 minus the 1. We know this. What are doubles? When you know 4 plus 4, doubles is like 4 plus 4. Sometimes back in my day, we were taught to memorize. We were taught that 4 plus 4 is equal to 8, and then 3 plus 3 is equal to 6. That's what it is. That's all it is. But that's as far as it goes. You can't do 4 minus 4 because you just get 0, and then 3 minus 3 just gives you more 0. So it doesn't matter, right? That's what I had to learn when I was a kid. And then there's a whole strategy, like if you wanted to do, I think it was 9, right? I think it was 4 to make a 9. See, that's the thing, right? The thing is they taught you they teach to look at the form, they teach you to look at the answer when they should be teaching you to look at the add-in. So Abacus teaches us to look at the add-in. This is the number we want to do. That's why this is broken up the way it is. These are the add-ins. Focus on the add-in. So if you notice, this is the 5 that we've been sitting on. Now we're trying to go to 7, and that's what we're sitting on too. I'm sorry, the 10s. These are adding of the 10. That means that if I want to add 8, right? If I want to add the 8, so I'm going to add the 8, and I want to add the 5, what do I do? Well, remember it was one of our formulas, plus the 5 minus, plus the 10 minus the 5. So my answer is 13. Lynette, do you go live every day? Yes, I go live every day, sometimes twice, and if I'm feeling pretty good, sometimes 3 times. I do morning math, afternoon abacus, learning lunch, midnight math. Last night I was actually working on the business, so I didn't go on live last night. I wanted to, but I needed to get some stuff out the door. There's a few people that bought some abacus, so I need to make sure that I got ready to ship today. And then somebody bought a book, so I had to get that ready shipped. And I was like, huh, cool. It's kind of, I'm hoping it works. I'm hoping this works. I'm hoping that this helps. Okay, so we're back to here. I'm going to be learning, I'm going to be coming to learn math from you. Oh, it's cool. Fantastic. You can, but you have to ask your questions. You're not allowed in unless you ask your questions. You have to ask the questions. I won't know if you don't know. Okay? Okay? Okay. I'm gonna be calling on you. When I see you, I'm gonna call on you. And I need to make sure that you understand. And you need to ask those questions because I ask a lot of questions. Okay, we're back to here. So minus the 7. Now, do we remember minus the 7 is take away the 10 plus the 3. Are we remembering this? So this is again adding the, okay, so what we're going to do is we're going to add the 4. Now notice I want to take away the 3 here. I want to take away the 3. What did I do? I want to take away the 3. I want to add the 3. Okay, sorry. There it is. So what I'm going to do is I'm going to use my little doohickey, this thing. So what's going to happen? Oh, wait, where's my other one? I've made so many contraptions because people were getting kind of confused. So this is what we're doing. We want to minus the 3 here. I was in your class. Your class is the only one I love to be in. Thank you, Mr. Clean. I appreciate that. Okay, so this is 400. Okay, this is 400. What we're going to do is we're going to focus on this number over here. Do they sell abacus with decimal points? Yes, decimal points right here. What are you talking about, April Ann? They're all... It doesn't matter where the decimal point is actually. You know why? Because when we look at it, we can choose any column to be our ones. So anytime anytime you choose a ones, the next column over will be decimal place. Yeah. Not a problem. So what's going to happen is if I choose this one to be my ones, then I move everything over, and then now this is my decimal place. Does that make sense? So it actually doesn't matter which indicator. It's an indicator. It's an indicator that you want to use, right? So this is a 13 column abacus. There are many indicators. Every time you choose the ones, every time you choose a specific indicator, the next column over will be your decimal. Hey, 500, welcome back. Yeah, so it's all about whatever is easiest for you. I feel like this is a lot better because I hate doing math on paper. Yeah. Oh my God. The new math is everything is on paper. And I'm like, that makes it so complicated. We could talk about new math, but I get really riled up. Oh my God. So, April Ann, does that make sense? So if I choose this one to be my ones, then my decimal will be here. And then I have all this number. Hey, Wesley. The problem is if I choose this one to be my ones, I have no more columns. So I would have to go all the way up to here to choose this one as my ones. So if I choose this one as my ones, right? Okay, good. Okay. I didn't need to beat it. I don't want to beat the horse. I don't need to beat a dead horse. Sorry. Yeah. Soroban made my equations easier, especially in my head. Yeah. Yeah, you know, that's the funny thing is, like, I could see certain things only because I know it the abacus way. For real. Okay. We're still back to here. Okay. Yeah, no, I love the questions. Keep the questions going. But if your guys are okay, I'm gonna continue on. So here, what we need to do is this 400. This is 400. This is 400. But I need to focus here. I found my people that get me in math. Yeah. You know what? Funny. I found people that are interested in Abacus. You know, I'm telling you. I'm telling you. I just started this trip, this journey to teach Abacus online, and it's been, I'm telling you, TikTok has been a blessing. So, what do we need to do is we need to take away the 7. That's what we want to do. We want to take away the 7. And I appreciate every comment and question that comes in my way. Thank you guys. So we need to take away the 7. Notice there's not enough beats to take away the 7. So what are we going to do? We have to do our formula. That's the formula. This is minus the 10 plus the 3. I'm going to rewrite it. I'm going to make it vertical. Because of you, I bought an abacus. You're my official abacus teacher. That's fantastic, Mr. Clean. That's funny. I mean, yeah. Oh, sorry. So, that's fantastic, Mr. Clean. So here, if you can look, I want to take away the 10 plus the 3. Does that make sense? So I broke it up, I made my equation, and I made it more vertical. So you will see, I need to figure that out. Okay, so you'll see, this is a 0, right? And this is 10, so that's what this is. Does that make sense? I want to, I'm actually interested. Okay, but the first thing I want to do is I want to add the 3, because I have the 3. So I'm going to add the 3 on my 1s. The question is I want to add the 10. Notice I don't have any beats to add the 10. Do you remember what we're doing here? We're going to take away the 10. But there's not enough beats to take away the 10. What do we do? Do you remember this? Right here? Minus the 1 is equal to minus the 10 plus the 9. Do you see how they build on each other? So what I'm going to do, I just bought an abacus. Ha! Bill, that's funny. This is super cool. Miss Letitia as well. She sells abacus as well. Thank you so much. Thank you so much. Yes, I do. I do sell the abacus. I sell this one specifically. If this goes well, I might invest to selling the bigger ones. So I'm gonna have to check it out. Oh yeah. Links in my bio, in my website. Okay. So we're back to here. We want to minus the 10, minus the 1. You can use the Abacus apps, but you can support Lynette by buying hers. Yes, thank you so much, Ethan. Yeah, the Abacus apps are fine too. Anyways, so minus the 1, right? Minus the 1. We want to minus the 1. Do we all understand that? But to take away the 1, what do we do? Sorry. Okay, we want to take away the 1, but what do? We have to minus the 10 plus the 9. So notice if I move it over, I plus the 10 minus the 9. Did that make sense? Minus the 9. Yes. Plus 9. Actually, plus the 9. Because we wanted to take away the 1. When we take away the 1, yeah. Right? Oh, sorry. Because there's not enough beads. There's not enough beads to take away the 1, so we got to do it again. We got to take away the 1. So we take away the 1, we add the 9, and we take away the 1. That's the formula. So when I look, my answer is, what's my answer? Anybody know what my answer is? That's my answer. I would love to do that. I hope more people come across our lives. Yes, I hope so too. You know, it helps that you guys like my lives and share it. Yes, right, Troll? Yes, Troll Keeper. Yes. So we have 393. But those were two-step equations. Why? Because we had to break down this and we added that. Minus, hey, Arc. Hi, Arkwell. -7. -7? Yeah, that's what we were doing. We were doing 400 minus 7. So the answer is 393. Yeah. I only hope those people love Abacus or more about Abacus. Yeah. I forgot the 10. Yeah. Oh, I see. You forgot the 5. Yeah, yeah, yeah. It's about attention to detail. That's the thing. And that's the thing that's interesting. Like the Abacus teaches you to look at teaches you how to look at things. And so if you notice, all of this happens in my head. All of this happened in my head. I if you really think about it, Abacus only tracks the numbers. You do this in your head. That's why this is called brain gymnastics, because you do all of this in your head and then you just move the beads. The reason why I write it out is so I can demonstrate it, right? I counted to 5,000 on my Abacus. Oh, that's cool. Oh, the 5. Yeah, that's the 5. So adding this is the 5. So that's what we needed to do. So it's 5, 6, 7, 8, 9. Yeah. 5,000 on your Abacus. That's funny. That's really funny. Did you do it by here, Mr. Cool? Mr. Clean? Did you do it by fives, or did you do it by thousands, or did you do it by hundreds? I can only do 2 digits per digit by a head, but sometimes 3 digits too. Yeah, but it all depends on how much how much I did by. Oh, of that's a lot of counting, Mr. Clean. But it's good because then you get to see what the beads look like and then you could practice it. That's what it is, really. It's about practicing. So did that make sense about like the numbers and stuff? You know what I should do is I should make one with one column and then I change it out to 2 columns. That's what I should do. I'm going to do that because it was kind of confusing. Yeah, I'll do that. I did it by ones. Yeah. Yeah. Anybody have any questions? So I think this one, yeah, I think this one, I want to do, I like this, but the problem is I got to flip it. So, anyways, yeah, I got these little flippy thingies. You know, I had these little flippy thingies because I made it for my son, and he was having problems with the equations. So I made it a little flippy thingy. Somebody said that's really cool, so I made it as a printable. All right, Mr. Clean, you're really bored. Okay, do you have them in different colors? I do not have them in different colors. I do not sell. I haven't figured it out yet because I wasn't sure if this was going to take off, so I haven't really bought these ones yet. This is a 13 column abacus. This would be recommended for adults who wants to learn abacus. The reason why is because you have more numbers. It took you 42 minutes? That's a lot of time. I have that abacus. Okay, good. So then after you do adding and subtracting, you can do multiplication. It'll be a lot easier to do multiplication on this one because you have a lot more numbers. You have a lot more digits. Yeah. This one is kind of nice for the younger kids, and then they get to graduate and become big people. But April Ann, do you have them in different colors? No, I don't. I don't have them in different colors. The only ones that I've seen was like this one, and I've seen this one. I've seen this one with like 13 columns, but I think 13 columns with this would be a little much. I like them small, and then I like to graduate the kids. I'm colorblind, so it's hard to see. Oh, so the brown one, is it hard for you to see as well? You know, Kramer. You know, there's a one called Kramer. It's called Kramer Abacus. Oh, no, this is hard. It doesn't matter what the colors are. It doesn't matter what the colors are. It all just matters where the position of the beads are, if that makes sense. It doesn't matter about the colors. It all matters about the position. So even here you have 5. I just wasn't able to see the blue. Okay, no. That's fine. But can you see this? The brown. But see, the thing is you have to pay attention to the position of the beads. It's not the color of the beads. Yeah, it's not the color of the beads. It's the position of the beads. So don't get hung up. So it's fine that you're colorblind. It doesn't matter. The colors mean nothing. The colors is just to make it look pretty. That's it. But the brown, if the brown is okay, then but you still need to pay attention to the positioning. The only reason why I use the colorful one because it's just easier for visual for the camera. But usually I would use the brown one, if that makes sense. I hope that's okay. Hold please. Yeah, keep using the color is fine. Okay, yeah, but no, it doesn't matter about the color. What matters is the positioning of the beads. So, um, okay, okay, yeah. If but I like also. Sorry. What I've noticed though with the colorful one, the bar is the height of the bar is bigger. So I think that's why I like it too, just because the height. I don't know if you could see that. Miss Light, can you do a quick multiplication problem? Yes, I could do that. Yeah. Okay. Um yeah. Okay, let's do a quick multiplication problem. Okay. This will be my last one and then I have a meeting to go to if that's okay. Can I do this? Can I put it in here? Okay. We'll do a multiplication problem. So, you want to do Mr. Clean, do you have a question or are we going to do what Ethan says? Because Ethan likes to push the class forward. Do you have a specific question, Mr. Clean? What Ethan says. Okay. Okay. Let me change different colors so then I can keep track. Okay, you know what? Okay, let's try this. Let's try this. Sometimes I feel like I just need a little push. Okay, not a problem. We do 18 times that by 43. This is so fun. It actually makes sense, and I don't know how I feel about it. Yeah, you're willing to learn math, right? Like, we always worry about, like, what is it? We always talk about having math anxiety. All right. The first thing we're going to do is we need to understand how many digits we have. Why? Because on the abacus, it's going to track our numbers. So what's going to happen is when I add these digits together, I will know where I'm going to put the number on my abacus. Abacus get me because it's clicks and the sounds, right? So thank you so much for the sharing of the live, April N. So we have 1, 2, 3, 4. We have 1, 2, 3, 4. We have 4 digits. So I know that I'm going to be here. How do I know? 1, 2, 3, 4. So because I'm going to be in the fourth one, now what am I going to do? I'm going to start multiplying it out. But to multiply it out, we are not going to do ones first. That's why. We're not going to do ones first. That's old people thing. We're going to do the new and improved. So what's going to happen is I'm going to put my finger back on the 4. I am going to take our left column, left and left. Hopefully you guys can see that. Definitely keeps my attention. So 4 times 1, that's it. That's all we're doing. We're not going to do new math. New math says 10 times 40. What we're going to do is we're going to strip away the complexities. This is really complex. There's too many zeros. I get confused. What we're going to do is we're going to do 4 times 1 is equal to 4. I know this. Why? Because it's super easy. And this is part of our multiplication fact. We need to know our multiplication fact. So here we are, but we know that this is a single digit. Because 4 is a single digit, I have to go back one column. That's all I have to do. Because it's a single digit, I go back one column, so I put my 4 here. That's it. Did that make sense? Was that too much information? There's also too much information. So I'm going to keep my finger here. The next I'm going to do is 4 times 8. 4 times 8. 4 times 8 is equal to... What is 4 times 8? Oh, hi! Hey! Hey, 4 times 8. This is actually my last. Thank you, thank you. 32. This is my last one. Currently, you have 400. Yes, currently I have 400. But don't pay attention to the 400. Pay attention to just the number. Just pay attention to the numbers. So I'm going to add the 3. We're doing multiplication. Yeah, but this is my last question. I got to go to a meeting. So I'm going to add the 3. I'm going to add the 3. Why? Why am I going to add the 3? Because I'm adding 32. I add the 3 and I add the 2. I add the 3. Can we do the 3? What is the formula for adding the 3? Do we remember? Do we remember how to add the 3? Yes. Plus the, add the 3 is the minus 2. Yep. So add the 5, take away the 2. I still need to add the 2. So I'm going to add the 2. Now what do I do? Well, I'm done with 4. So because I'm done with 4, I have to recount it. What is my next number? What is my next place value? I'm going to try this. My next place value is 3. 1, 2, 3. So I go 1, 2, 3. Good luck with the meeting. Thank you so much. So what do? 3 times 1 is equal to 3. What do we do? 3 is a single digit. What do we do? If I'm here, 3 is a single digit. What do I do? Thank you so much for the likes. 3 is a single digit. I go back one column, right? And I want to add 3. I got to do that. So I add 3. Do it again, right? I move back one place. I move back 1. Thank you so much for the like, Ella. So what is it? So do I have enough to add the 1? Add the 3? No. What do? I need to plus the 5. Here, this is where... No, that's the wrong one. Is it this one? Oh my gosh, I have too many now. Add the 3. So if I add the 3, what do? Right. So this is where this comes in. Notice that there's an imaginary line. There's a add the 5 and take away the 2. So I added the 3. Now what do? What's my next question? My next question is, so I did the 1. My next question is 3 times, I think it's easier to remember if it's, yeah, exactly, Sasha. Some people, I like to see it as 0, 3. Some people don't. So it is what it is. But what's the next number? It's 8. 3 times 8. 3 times 8 is, what's 3 times 8? What's 3 times 8? 24. Thank you. 24. So the question is, can I add the 2? Yes. Can I add the 4? Yes. So my answer is 700. Right? That's my answer. 700. Yes. Does that make sense? 774. Yes. Thank you, Cruel. Yes. Yes is cool. Yes, Beal. Right? Make sense? Simple. But see, the thing is it goes back to you need to know your formulas. And then you just add everything together. But we did we did all of this, right, in our head. We did this calculation in our head. I just wrote it out. Abacus made multiplication to VCE. Yeah, it does because you have conversations with it. Thank you so much for helping me understand. Yeah, not a problem. Thank you for joining me. Thank you for joining me. I appreciate everybody here. Thank you so much for liking my. Oh my God, 16 likes, 16,000 likes. That's crazy. Thank you guys. Thank you guys. I don't fully understand it. Oh well, but there's next time. Yes. Hey Hap. Thank you. Yeah. You know, Troll Keeper. We just got to go back and understand how to do the formulas, and we'll be good. Bye. I will see you soon. Yes, I will see you in my next live. Bye, everybody. Thank you so much for commenting. Have a good day. If I don't see you later, bye. The formulas confuse me. Yeah, we just got to take it slow. That's all. Sad you have to go. Yeah. Bye. See you later. Have a good day. Troll Keeper. It gets confusing with the formulas, but it's just because we need to know it. See you later. Bye. Bye, Beal. Thank you for the tiny. You need to memorize it all. Yes, as you memorize all the formulas, it will get easier. Don't forget, I've been doing this for 20 plus years, so it's easy for me. It just takes time. Just takes a little bit. Bye. Okay, I'm going to end the live.